So in this lecture, we are going to look at organic reaction mechanism. And to begin, we are going to look at the general introduction to organic reaction mechanism. Now, I would love to define what reaction mechanism is. Reaction mechanism is the step-by-step processes in which reactants are converted to products. Now, there are two types of reaction mechanism that you are going to do in your organic chemistry. And these are, one, we have what is called the consacted mechanism. And then the second one is the stepwise. In the consacted mechanism, we can explain it like this. When the reactant, let's say A and B react, it is directly converted to product, let's say C plus D, without going through any phase or any other step. Are you getting it? Consacted, from reactant directly to product. However, in the stepwise mechanism, when A and B react, they pass through another stage. Are we getting it now? Let's say stage E, before it will get to C plus D. So this kind of reaction mechanism is known as the stepwise mechanism. Now, this E here is what is called the reaction intermediate. Reaction intermediate. Intermediate means it is in between the reactant and the product. And the reaction intermediate we discussed them in our previous lectures. We said we have what is called the carbocation, and then we have what is called the carbanions. Now, the carbocations are also called carbonium ions, while the carbanions, they are negatively charged ions. These are positively charged and these are negatively charged. Now, this is what you need to know about the general overview of reaction mechanism. Now, if you looked at the last video we submitted, or the last lecture we had, you agree with me that we discussed on the processes or how reaction mechanism is written. We said they are written by pushing of arrows. If you use full arrow, it means you are, or let's say not just arrow, not straight arrow, but coily arrows, something like this. If you use a full arrow, it means you are moving a lone pair of electron or you are moving a bond. However, when you use a half arrow, it means you are moving a radical or one electron. Is that not so? Now we discuss what a radical is, the product of what kind of cleavage? Homolytic cleavage. While the cations and the anions are product of what kind of cleavage? Heterolytic. So this is the summary of all that we learned. Now, generally, there are three classical organic reactions. The three classical organic reactions are, we have one, the substitution reaction. I'm going to use this to indicate reaction. Two, we have addition reaction. And three, we have elimination reaction. Now, these three reactions are what are considered as the classical organic reactions. Now, there is a fourth kind of reaction that is not classified as a classical organic reaction, and that is what is called the rearrangement reaction, as in the form of the keto-enol tautomerism that we are going to look at later. So, rearrangement reaction is not part of the classical organic reactions. Now, different functional groups undergo different types of this reaction. Now, some functional groups can undergo more than one. For instance, the alkyl halides undergo elimination reactions and then substitution reactions. And then also the carbonyl carbons, which are those of the aldehyde, and ketones, they undergo both substitution reaction, and then we also have addition reactions. But we are going to look at each of these later. Now, talking about our focus for this lecture, we are going to look at the alkyl halides and their reactions. Now, the alkyl halides are classes of compounds that have the general formula of ROX, where RO is the alkyl group, which has the general formula of CnH2n plus 1. Now, we said alkanes have general formula of CnH2n plus 2. Now, if you subtract 1 from here, because we said alkanes are formed, or alkyls are formed when alkanes loses 1 hydrogen. So if you subtract 1 from here, it becomes 2 minus 1, which will give us this plus 1 here, which has the alkyl group. Is that understood? So this X present in the alkyl halide is a halogen, which can either be chlorine, fluorine, bromine, or iodine. So if you are going to write the general formula of the alkyl group and the halogen, we now say that general formula of all alkyl halide is CnH2n plus 1, and then we have X. Now, if it is a bromine, you now have it as CnH2n plus 1, then Br. Now, in a case where n is equals to 1, this will be equals to C1, H2 times 1 is 2 plus 1 is 3, C1H3Br, which can be written as CH3Br. And then we call this methyl bromide. So these are the various, this is the general formula of the alkyl halide and their general form. Example, methyl bromide, we have ethyl bromide, or you can also call them, either you call them the alkyl halide, or you can call them the haloalkanes. So another name for the alkyl halide is either you call them the alkyl halides, or you call them the haloalkanes. So either you call them the alkyl halide, or you call them the haloalkanes. Now, having looked at this, let's talk about the two kinds of reaction that the alkyl halide or the haloalkanes undergo. So we are going to write here reactions. Now, the two types of reaction they undergo are, it's either they undergo substitution reaction or they undergo elimination reaction. Now, the substitution reactions of alkyl halide can further be classified as, so we are going to take the substitution now and then further classify it. So the substitution reactions of alkyl halides can further be classified as, we have 1 SN1, which is substitution nucleophilic unimolecular or SN2, which is same thing as substitution nucleophilic, but this one will be bimolecular. Then we have the elimination reactions are further classified into 2 also. So, into 3. Elimination reactions are further classified into 3. We have what is called E1, which is elimination reaction, electrophilic elimination reaction, unimolecular. Are you getting it now? And then we have E2, elimination reaction bimolecular, and then we have what is called E1CB. pseudo. Now, these are the various kinds of reactions that the alkyl halides can undergo. Now, let's look at each of the examples. Or, before I talk about each of the examples, now, because alkyl halide can undergo these two types of reaction, they can undergo either a substitution reaction or elimination reaction. We can then say that there will be a competition between substitution reactions and elimination reaction wherever you find the alkyl halides. Let me go over that again. That because alkyl halides can undergo substitution reaction and elimination reactions, whenever an alkyl halide is present to undergo a reaction, there will be a competition. If the substitution reaction is what will happen, or elimination reaction is what will happen, or it will be 50-50%, there will be a competition. Now, there are various criteria or conditions that will favor the substitution reaction, and there are other conditions or situations that will favor the elimination reactions. So let's look at examples here. For instance, if you have, let's say, this is an alkyl halide. Let's say CH3, CH2, and then this is Br, and then you react this with a base. Now, this base, first of all, let's react it with a nucleophile. Now, if it reacts with a nucleophile having SS electron, this can react to remove this bromine group from here, and then when this bromine group leaves here, the nucleophile attaches. So this is going to give us CH3, CH2, and then the nucleophile attaches here, plus the bromine group with its electrons will form something here like this. Now, this kind of reaction, what happened? You discover that this nucleophile here came here, removed bromine left, are you getting it now, to form this product. So we say this kind of reaction is substitution reaction. Now, however, if you have it in such a way that you have CH3, CH2, Br, plus let's say the something that is there is not a nucleophile but a base. Now, if the product of this reaction give us something like this, CH2 double bond CH2 plus, let's say, plus the H B arrow, H plus base, plus B arrow minus, we say this kind of reaction is the elimination reaction. So you can see elimination reaction, the major features is it leads to the formation of a double bond. All right, as you can see here, elimination reaction leads to the formation of alkenes, doubly bonded compounds. So whenever you see that an alkyl halide react with a base to form a double bond of alkene, you say such a reaction is an elimination reaction. So this reaction is elimination. Like I said, that whenever you find alkyl halides, there's a competition between elimination reactions and substitution reaction, because the two reactions can occur based on the condition present. If the reagent present to react is more of a nucleophile, it's more nucleophilic as compared to its basicity, then it may undergo substitution reaction. And also based on the nature of the alkyl halide, based on the nature of the solvent, and some other conditions that need to be satisfied. But in this lecture, what we are going to look at is the substitution reactions, which is SN1 and SN2. But before we talk about that, let's take this class exercise together. Now you have a compound like this. Recall that I said that the substitution elimination reaction usually leads to the formation of a double bond, while substitution reaction, the nucleophile attaches to where the bromine is or where the halogen is, and the halogen leaves here to form a neutral or an ion here, which may react with the other group attached to the nucleophile to form a neutral compound. Now, when we write more reaction mechanism, you'll be able to understand what all these are all about. So let's come here. Say classify each reactions as substitution, elimination, or neither. Identify the leaving group in each reaction and the nucleophile in substitution. Now, before we talk about this, listen. let me label this reaction. Now, as you see this reaction, this group here, which is the bromine group that is leaving here, is what we term as the leaving group. All right, this is the leaving group, and this is the nucleophile in this reaction. All right, so this is the leaving group and this is the nucleophile. Is that understood? For substitution reaction, the group that leaves for the nucleophile to attach is what is called the leaving group. Now, a combination of the leaving group plus the alkyl, or let's say the alkyl halide generally, is what we call the substrate of this reaction. So the alkyl halide is called the substrate, while only the bromine is called the leaving group. Then this NU here is called the nucleophile. All right, and these of course are the product of the reaction. Now, this reaction is a synthetic tool for the manufacture of so many organic products by just using a more powerful nucleophile to substitute another group from the compound or the alkyl halide that is given. So let's identify each of these as either substitution reactions, elimination reactions, or neither, or identify the leaving group in each reaction and then the nucleophile. Now let's look at this reaction together. First of all, which of them is the leaving group? We said the halogen that is leaving is mostly the leaving group. Or first of all, let's identify, is this substitution reactions or elimination, or neither? Now, if you look at this reaction, this is bromine, right? This is OCH3. This is the nucleophile here. This is positively charged. This nucleophile here does what? It attacks this bromine group here, and then it forms OCH3 plus sodium bromine. All right? This OCH4 here, this group here, this is supposed to be OCH4, not 3, OCH3 rather, not 4. So this group here that is coming to attack here is what we call the nucleophile. All right, so this is the nucleophile, and then this group that is leaving here is what we call the leaving group. So automatically, this reaction is a substitution reaction. So that's the ability to identify if it's substitution or that. We know elimination will give us a double bond, all right? Now let's come here. Look at this reaction. What kind of reaction is this? Is this substitution, elimination, or neither? First of all, look at the double bond. A double bond is being formed here, right? And then this OH and this H is being, or this OH and one hydrogen from here is being removed. So we can say that this reaction is purely elimination reaction. So we come here and say this is elimination reaction. So we don't have any leaving group here. If there's any group that is leaving here, it's supposed to be this OH and one hydrogen from here. All right, one hydrogen from here. But this reaction is elimination reaction. Why? Because it forms a double bond, and this OH here is being removed. Elimination, to eliminate, means to remove from somewhere. All right, so when you say elimination reaction, it means we are removing something from somewhere. Now let's look at the next. We have this. Say classify each of the following as the same question: is it elimination or not? Now if you look at this reaction very well, you agree with me that this reaction is not looking like elimination, but at the same time it's looking like elimination reaction. But we can't actually say it's elimination. Do you know why? Because we have this bromine group here and this bromine group. There are two bromine groups there. Now elimination reaction is a reaction whereby these two groups, one of these will leave, hydrogen and bromine will leave. Are you getting it now? And then to form, or we can say this is elimination. We can say this is the halogenation reaction, whereby two halogens are removed from this compound, so it forms a double bond. So we can say that this is also elimination reaction. But this one you need to be very careful. All right, so that is how to classify them as either elimination and the rest. Now let's look at the next thing. We said the alkyl halides and nucleophilic substitution reaction. Now nucleophilic substitution reactions are classified into two. Talking about the substitution reactions of the alkyl halide now. You know we said that the alkyl halide undergoes two types of reaction: elimination and substitution. So we are looking at the substitution reaction now. Now the substitution reaction of alkyl halides are of two types. We have the SN1 reaction, which is substitution nucleophilic unimolecular, and then we have the SN2 reaction, which is the substitution nucleophilic bimolecular. Now, SN1 reaction is a stepwise, it follows a stepwise mechanism. And then SN2 reaction follows a concerted mechanism. Now, there are various conditions that must be fulfilled for a reaction to be what? SN2. So let's take SN2 reaction, the general substitution nucleophilic substitution. What is the form of it? The form of it is you have something like this. Let's say C, this Br, right? And then you have, let's say, these are bonds that may contain hydrogen. Now, if this bond reacts with a nucleophile, the general form of substitution reaction is what I'm trying to write. Now, what is going to happen? This nucleophile will come here, remove this bromine will leave, and then the product of this reaction will be something like this: C, nucleophile, and then bromine, plus Br minus. This is the general form of all nucleophilic substitution reaction. Of course, you know, bromine will still have its 6 or 7 bonds, 6 bonds around here. All right. So this is general form. Now we said this group here that the nucleophile react with is what we call the substrate. So this is the substrate, and then this here is the leaving group, and then this is the nucleophile. Of course, this is the product, and then this is the group that is given off. So this is general form of all nucleophilic reactions. Now, what are some of the conditions that must be satisfied for a reaction to be SN2? Now, one of the condition is, or let me see if I wrote that condition here. Okay, no. Now, one of the conditions that must be satisfied for a reaction to be SN2, it must have a powerful nucleophile. All right, powerful nucleophile. Number 2, it must either use a primary alkyl halide. Let me use arrow S to represent alkyl halide, or manageably secondary or 2 degree. It's either primary or manageably secondary or 2 degree alkyl halide. And then another condition is the reaction must be concerted. So when it is concerted, that means the reactant are already converted to product, then it's SN2 reaction. Now, another thing is that SN2 usually occur in non-polar solvent. Non-polar solvent. Now, the next condition is SN2 reaction. The product of SN2 reaction is usually, it gives an inversion of configuration. We are going to look at what we mean by inversion of configuration. That means configuration. We are talking about the stereochemistry. We are going to look at what it's talking about. Now, in your first semester, you learned, or year 1 and year 2, you learned arrow and S configuration, right? Which we have said is absolute configuration. Arrow means rectus, S means sinister. So if the initial reactant was arrow configuration, it means the product must be what? The S configuration. Is that okay? If the initial product were S configuration, initial reactant was S configuration, it means your product will be inversion. That means the configuration will change to another one, which is the arrow configuration. Now, another thing is that another feature of SN2 is the kinetics. Is first order kinetics. Second order kinetics. Second order kinetics. That means it uses the substrates and the nucleophile. All right, and then finally, the molecularity is bimolecular. That means the two substrates and nucleophile are involved in the rate determining step. So it's bimolecular reaction. I believe these are some of the things that you must look out for when talking about the SN2 reaction. And SN2, there's no formation of any form of reaction intermediate. So let's look at reaction of iodomethane with hydroxide ion. The product is methanol. This is an example of SN2 reaction. Iodomethane is something like this. CH3I, right? Plus hydroxide ion is OH negative. When this react, this is going to form CH3OH, which is methanol, plus what? The iodide ion with, of course, is lone pairs of electron. So what do we call this? We say this is what? Iodomethane or methyl iodide. Alright? OH is called hydroxy group. Alright? This is called methanol. And this is called the iodide ion. Now, how does this reaction occur? The mechanism of this reaction. Now, I said that SN2 has a very simple mechanism, right? It has a very simple mechanism, which is C, you have I, C, you have I, and then you have hydrogen, 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 plus OH negative, right? Now, what I'm going to do is very easy. The nucleophile comes, it attacks this carbon here. All right? As the nucleophile attacks this carbon, this one here, iodine, has no choice than to go away with its electron. Are you getting it now? And leave this place. So, you remember that when this group is coming here, you know I drop from the nucleophile down to the carbon. It forms a carbon nucleophile bond, right? Which we give this product as expected. So we have H, C, H, H. Here is what? OH plus I negative, which is the iodide ion that leaves that place. So this is the product of this reaction, and this is the reaction mechanism. Now you discover that what we used for this reaction is methanol. I mean iodomethane, and iodomethane is primary alkyl halide. All right. By now you should be able to distinguish between a primary alkyl halide and a secondary alkyl halide. All right. So that is for that. Now the next one we are going to look at is the energy diagram of the reaction. We are going to look at the energy diagram of the reaction. Now we have this as the energy diagram. Now to this side, what you have here is the energy of the reaction. So I'm going to write here energy, and then here what you have is the reaction coordinate. How the reaction is proceeding. Reaction coordinate. Now, if this is the energy, you should note one thing when you are drawing energy diagram. Note that the energy of reactant are always higher than those of product. Right? Energy of reactants are always higher than those of what? Product. So let's say the reactant starts from here, and then we are going to draw it from here like this. I've drawn it too high. Let's say these are the reactants. Sorry. All right. Now you see the energy of the product, the way I drew it, is lower than those of the reactant. Now at the beginning part, you have the nucleophile. Since it's SN1, SN2, it involves both the nucleophile and the substrate. So you have the nucleophile, and then here, carbon, hydrogen. Let's say this nucleophile is having negative here. Hydrogen, hydrogen, and there you have the iodine. Now this is the nucleophile and this is the substrate. These are the reactants. All right. Now as this reaction is proceeding, at the transition state, Now the transition state is not the same thing as the reaction intermediate. Now the transition state is a high energy state in which the reactants are converted to what? The product. It's at that state that the something is just like a mixture. Like the reactants are not directly converted. Let's say the transition state is like a state where the reaction is occurring like a baton. When somebody pass up a baton to you, that state at which you are holding the baton and the person is also holding it is what we call the transition state. Are you getting it? And then after the person forward the baton to you, what happens? You start running the race. Is that not so? So we can say the transition state is that state in which the product is still present and the reactant, they are still present. The product is not completely formed, and then the reactant has not completely lost its what? Iodine, which is the iodide group here. So at the end of the day, this is going to give us something like this. You are going to have C, this hydrogen, hydrogen, all right? And then you are going to have hydrogen. You are going to have, now in this place, you don't put a full arrow to indicate this, but rather you use dotted lines. So we have 1, 2, and you have OH, and then you have something like this, and then you have iodine. All right, now this is to tell you that the iodine has not completely left, and this OH here is not completely formed. All right, so at the end of the day, this will transition. Now what is the total charge here? This one here is negatively charged, right? Partially negative. This partially negative. Why this is partially positive? All right, so negative, negative, positive. There are, let's say this negative cancel this negative, the positive here, positive cancel negative here, so we are left with one negative. So the charge here is negatively charged. So you can put a negative charge there. Now this one is telling you that it's a high energy state. All right, that's the meaning of this plus plus here. It's not plus plus, it's something like this. It's telling you that it's a high energy state. Then the product of this reaction will be something like this, which is you have C, and then you have hydrogen. Here you have OH, and then you have hydrogen, and then you have H. This is the product of this reaction, plus I minus, which is iodine. All right, so this is the energy state of, or the energy diagram. Now you may be asked to draw the energy diagram for SN2 reaction. This is what you're expected to draw. Now, but in that case, for SN2 reactions, they will just say SN2. You don't need to start drawing any of these reactants. You can just put hydrogen, hydrogen, or put bonds here to indicate. All right, so that is that. Now, another reactions of SN2. Okay, let's leave this for the next lecture.